So we know how to use the quadratic formula now to solve a quadratic equation, but it'd be nice if we could have an idea of what we're getting ourselves into before we even do the problem. What I mean by that is it'd be nice to know, well, okay, am I going to have imaginary answers? Am I going to have real answers? Will there be one answer? Will there be two? Just kind of knowing that info before you do the problem. And it turns out that in our quadratic formula, the part that's kind of the most important that'll help us out with this is this inside the square root right here. This part inside the square root is actually what decides the number of answers we'll have and what type they'll be. And it's important enough that we give it its own vocab word. So this thing inside the square root has a weird name called the discriminant. So the discriminant is b squared minus 4ac. And it's given its own name because it's kind of an easy way to tell what kind of answers you're going to get for a problem. So the inside of the square root is called the discriminant, and based on whether the discriminant is positive, negative, or zero, we know what we're going to be having for our solutions. So if you do the discriminant in a problem and it's greater than zero, so in other words, if it's a positive number, you're going to have two real solutions to your problem. So if we were to graph this, like we've talked about before, there'll be two x-intercepts here because there are two real solutions. And that kind of makes sense because if there was a positive number under here, we'd have a square root and then we'd split it up into our two separate problems and we'd get answers. So they'd be positive square roots, it'd work out fine. Now if b squared minus 4ac is actually equal to 0, so it is 0, there's only going to be one real solution. So if we graphed it, the parabola would only hit the x-axis one time. So it hits right there and that's it. And that also kind of makes sense because if you do your two branches, say this thing here was a 0, the square root of 0 is still just 0. So when you split it up into two separate fractions, you're going to be doing plus or minus, basically for this branch, 0. So it's the same thing twice, which is why there's one solution. And finally, if b squared minus 4ac is less than 0, so if it's negative, you're going to have two imaginary solutions. And if you graph it, it won't ever hit the x-axis here because the solutions are imaginary. And that also makes sense because when do we get imaginary answers? Well, when the square root is negative. So if the thing under the square root is negative, obviously we're going to get imaginary answers. So it kind of makes sense if you think about it a little bit. And all we're going to do in this video is practice these new rules on 3 problems. We're not actually going to solve the problem. It didn't ask us to solve here. It just has to say what kind of answers there are going to be. So if the problem said solve, you wouldn't even necessarily have to do this. But if it's asking you just to say how many answers, that's exactly what the discriminant is for. So instead of doing the whole problem looking to see what our answers are, we're just going to do b squared minus 4ac. That's going to tell us what our answers are. So we're going to do 49 minus 4 times 3 times 10 is going to be minus 120 here. 49 minus 120 is negative 71. My answer is negative. That means the inside of my square root is going to be negative. That means I will have two imaginary solutions. I don't know what those solutions are, but I know that if I do the problem, I should be expecting to see an I in my answer. On the second problem here, if I do b squared minus 4ac, I get 36 minus 4 times 1 times 9 is 36. I get 0. If it's 0, that means there will be one real solution. And on my last problem, if I do b squared, let's see, that'd be a 49 minus 4 times a times c. I get a positive answer here. There will be two real solutions. This doesn't actually tell you what the solutions are. It just tells you how many of them there will be.